Hey, this is Dave with OC Astronomy. Welcome to our last set of material for Openstax and for the lectures that we're going through in our study of astronomy. And I hope that you feel like the men of Mission Control of Apollo 13 felt that failure is not an option. I want you to finish strong, study hard, finish your quizzes. This week we're going to give a look at chapters 8 and chapter 30. And you may be asking yourself, why do we take this circuitous route that we did and studying the chapters in Openstax, and I didn't really follow them in numerical order? Well, I wanted you to see from the big scope of the Milky Way and other galaxies how stars form in groups and nebular clouds, how you have to have a couple of generations of stars before you get heavier elements other than hydrogen and helium, and how those stars have to die, and you get planetary nebula, you get supernovas, and that material that was in those original stars spreads out to become the seeds in other nebulas. All of that is to explain how the Earth is, where it is in the universe, where it is in the galaxy, how the Earth has come to be, and some very special things about the Earth that through my study of astronomy, and I hope through yours, you've seen kind of how rare and special the Earth is. And also in chapter 30, it talks about the search for extraterrestrial life, or intelligent life, which is something that's on everybody's mind for pop culture. And I think it's an interesting way, some thought-provoking ways to conclude the chapter. So without further ado, let's go up to the board and look at a couple of things that we've learned about the Earth that you'll see in chapter 8, along with some other principles. So some of the earliest to study the stars were the ancient Greeks, and you had Aristotle and some of the other philosophers who thought that the Earth was the center of the universe because it was the heaviest thing, and that lighter and better materials floated like flames and clouds and stars, and so they were naturally up at the top, and the Earth with its coarse and crude matter was located at the bottom, and that put the Earth in a place of the center, not because it was special and wonderful, but because it was kind of the trash heap. If you've seen the movie Thor Ragnarok, kind of a random one to throw in there, but the planet that Thor lands on in Thor Ragnarok is a planet that's basically at the bottom of the universe. All of the other cosmic openings open to that planet, and it becomes basically the trash pile planet of all the rest of them. And that's kind of how Aristotle and his crew believed that the Earth was, because it was the heaviest. Everything heavy is bad because it's more material and it's denser, and only the lighter things and the better things are free to float above. But we know that's not the case. We know that the Earth actually is not in the center of the solar system. Good old Copernicus showed us, whenever he improved upon Ptolemy's model, Copernicus showed us that the Earth indeed does go around the sun, and we call that Heliocentrism, and I hope that you remember that. But that the Earth does go around the sun. But there's some special consequences of the fact that the Earth does go around the sun and not vice versa, and that the Earth is not at the center of the universe. So let's have a closer look at the first set of conclusions. First, in the nebula cloud that eventually formed the star that became the sun, it was a dense cloud of different kinds of ices and grains and dust, and they would have been all kinds of chemical elements that we're familiar with on Earth today, like carbon and iron, uranium, hydrogen, helium, nitrogen, oxygen, all the wonderful things that the Earth and all the rest of the planets are made out of. And from that, those things condensed into planets. We know that the rocky planets condensed closer into the sun, and that the gas giants condensed a little further out, and that put Earth about where it is, being the third rock from the sun as it is. So one of the consequences, though, of where our planet formed is that it's in something called the Goldilocks zone. The Goldilocks zone is a place where the sun's heat heats up the Earth just enough for there to be liquid water, but doesn't heat it up too much, because the inner planets, Mercury and Venus, don't support life because they can't have water on their surface. The water would be too hot and boil away instantly. So we're in this special spot in the sun, distance from the sun, that allows us to have liquid water and allows us to have breathable oxygen. And so that's a nice place to be, right in the so-called Goldilocks zone. You'll see some more things in chapter 8 about what makes the Earth special, and I hope that you pay attention to those whenever you're reading it. But I just wanted to point out a few of them as they are. First off, in our place in the galaxy. So in our spot in the galaxy, it was thought originally when William Herschel and some of the others that studied the structure of the galaxy, they first put us in the very middle. And if you remember the great debate with Harlow Shapley and Heber Curtis, they were debating about the position of the sun and the Milky Way. And Heber Curtis put us right in the middle, and Harlow Shapley put us out on one of the arms. Now, some people would say, well, that makes us less significant because we're not in the center of things. But if you think about it, if you were in the center of the Milky Way galaxy, you'd be in the middle of a supermassive black hole. That would not be a friendly place to be. And plus, the stars and things in the center, there's a lot more, the stars are a lot closer together, and so you get a lot more bathing in in gamma radiation and in X-rays. So the center of our universe, our center of our galaxy, for that matter, the center of our galaxy would not be a friendly place to be because we'd be exposed to all kinds of bad radiation. Now, what about out here, way out on the arms? Well, out here far on the arms, we know that there are stars, but they have a lot lower metallicity, or you don't ever hear that word pronounced. Metallicity. They have less metals in them, and when astronomers say metals, they mean anything heavier than helium. So the stars that are out here in these arms, they don't have the carbon, they don't have iron, they don't have some of the heavier elements because they're not in close enough proximity to stars that have gone through their life cycle and then filtered that material out. And so only in here in the middle of this band do you get stars that have the right chemical composition, such as carbon and oxygen and iron and things that are supporting life here on Earth. I've mentioned iron quite a few too many times. Why is that so important? Well, we know that early on in its formation, when the Earth was still kind of molten and shifting around, it was hit by something called the Great Impactor, or the proto-moon, if you want to call it that. And that body was probably about the size of Mars, and it had probably a metal core in it. And we've explained how whenever that hit the Earth, the metal core, because it was so dense, kept moving and joined the material of the Earth, but the material of the crust of that early planet hit the Earth and impacted it and mixed with some of the crust that was knocked off of the Earth and became the moon. And those silica rocks that the moon's made out of, the moon does not have an iron core. And the core that was donated to Earth joined ours and became our iron core. And that's really, really important. Another thing is, earlier in our life cycle, Earth had to have been hit by a comet or two that brought with it a lot of water. Comets are made of liquid water, of frozen water ice, and that frozen water that the comet brought is now given the Earth a covering of water on its surface. Now, the iron core that is in the center of the Earth is really important for us to be able to sustain life here. Because the Earth is somewhat tilted, and because the Earth is spinning around, that iron core is super important. The iron core has, the first part of it is molten, and then the inner part of it is probably solid. And the interaction between that solid and liquid rotating hot metal produces a very strong magnetic field for Earth. And if it wasn't for that magnetic field, we probably wouldn't have an atmosphere, and we probably wouldn't have life on Earth as we know it. The solar wind blows from the sun and hits that magnetic field and gets shifted around to the poles, and then also it can be shifted around to the backside and then break off. If you were to look at a picture of the Earth and be able to see the effect of those cosmic particles, you'd see that we're being bombarded constantly, but that those particles get directed around us. It's almost like the Earth has a force field. The other thing is that having a moon, like we do, has actually stabilized the tilt of our planet, which has caused our planet to be, for better or worse, like a rotisserie chicken. We get the effect of the seasons, and so you get temperature variation between hot and cold, and some think that has stimulated the evolution of life on Earth. So another thing about the Earth that's really special is the upper level of our atmosphere. It's made of ozone, and that ozone layer is very important because it protects us from UV radiation. UV radiation, I don't know if you've ever seen ways to get rid of bacteria, but one way to do it is you can shine UV light on clothing or whatever else, and it sanitizes them. It's been used to kill microbial life, and if it wasn't for the ozone layer around Earth, that microbial life, including our early, if evolution is the way it happened, then those evolutionary ancestors would have been wiped out with that strong dose of UV radiation. So that's one good reason to be thankful for the ozone layer. The other thing is the greenhouse effect. Because we have a water atmosphere and because we have water in our atmosphere in gaseous form and water vapor is actually our strongest greenhouse gas component. And greenhouse is a really important thing because it helps trap the sun's heat in the atmosphere, and the radiation doesn't bounce back off into space right away. And it kind of acts as a thermal blanket for Earth and keeps the Earth at an average temperature that's nice, that's in the range of 60 degrees or so. But if it wasn't for that, then we'd have really hot temperatures on one side where the sun was, and then on the back side of the Earth where the sun wasn't shining, you'd get really cold temperatures, and those wouldn't even out. So you'd have a hot side hot and a cold side cold, and every day it'd go through really huge temperature swings. But because of the greenhouse gases that is in the form of water vapor and carbon dioxide, then we get a nice, stable, more even planetary temperature, which is good for all of us. Now, the other thing about Earth's position where it is that you got the planet Jupiter out there is 9/10, I think, of a mass of our solar system as far as the planets go. And Jupiter, being in the position that it is, catches a lot of infalling debris. So comets and asteroids and things, a lot of those things wind up hitting Jupiter, or Jupiter collects them as like a comet will pass by, like Shoemaker Lever 9, and we've seen that footage where the comet goes around the sun, and then on its way back out, it runs into Jupiter and gets absorbed by that atmosphere. So one good thing about Jupiter being out there is that it provides kind of a shield in a gravitational way to keep all the rest of that junk from hitting the Earth. So Earth is a really special place, and it's nice that we are where we are. We're in the Goldilocks zone for water. We're also in the galactic Goldilocks zone to be habitable for life. And so it's really important that we appreciate that. In fact, in chapter 30, it talks about the search for extraterrestrial intelligent life, the Seti project. And so the Seti project was dreamed up kind of in the 70s. It's been thought of before that. The idea of radio telescopes is older than the 70s, but around then it got a little bit more impetus, I guess you'd call it. A guy named Carl Sagan was kind of influential in this project, along with a guy named Drake. And Drake was a radio astronomer, and he had a kind of an idea. He was on the original board for Seti, and when they got together, they needed something to talk about. And so his first agenda notes that he brought in, he put something up on the chalkboard called the Drake equation. It's not really what you call an equation. It's more of a thought experiment. But in that equation, it gives you the odds of finding intelligent life that we could communicate with. And it goes something like this. You want to see about the rate of formation of intelligent life, and then times the number of years that life has been around, and the number of years ranging from how long has it taken humans being on this earth to develop radio signals And if you think about that, you have to have technology, you have to harness electricity, you have to have some kind of electronics technology, and then you have to be able to transmit radio frequencies from one side of the Earth to the other. And so as the Earth now, human beings are putting out a big signature of radio emissions from the planet. And so you have to think about who else might be out there listening to us if there is extraterrestrial life that's intelligent, and are they emitting, first off, are they emitting radio waves, and are they then detecting radio waves? And so you have to look at the fraction of stars that would have planets. Now, we have learned that it turns out planets are a lot more common than they thought at the time. We have done a lot of exoplanet research, and we found a lot of planets. Unfortunately, though, a lot of those are hot Jupiters, are big planets that are close to their star. They're not anywhere in a habitable kind of situation. They have been able to find a few that might be Earth-like in a habitable zone, but back then they thought that they were even more rare. Nowadays, we know that there are planets out there to look at. And on those planets, you got to look at the fraction of them that are habitable. And we've looked at that Goldilocks zone idea of how many might be able to support liquid water, how many of them might be in a situation where they have maybe an iron core that would provide a magnetic field that would shield them from the sun's from their star's radiation. And then are they UV protected? Do they have a layer in their atmosphere that blocks that UV light that would keep from sterilizing any small organic or bacterial life that might come around? And so are they habitable? And then of that, what is a fraction of them that could support life? And that meaning long term. Do they have like an axial tilt that would support a seasonal change that would support the growth and development of diverse kinds of life? But anyway, do they support life, and are they habitable? And among those that support life, how many of them have developed intelligent life? Well, it's one thing to say, yeah, you got microbes out there, and maybe there's even microbes on Mars. Maybe everywhere that we look, we're going to find smaller, critters out there. But have they developed intelligence? And then finally, of that intelligent life, how many of them have developed intelligence to the degree that they're able to manipulate electronics and create and detect radio signals? Are they able to broadcast and send electromagnetic radiation over the air? And so that number, if you look at it, is a pretty small number, probabilistically speaking, that you're going to have life on another planet that can support intelligent life, and have that intelligent life be able to harness the electromagnetic spectrum. Now, in that, the other factor is time, because you're going to have 1,000 to 100,000 years that a civilization might be stable. Because as we've seen, we've only been able to harness the electric magnetic radiation. We've only been able to harness that for 100 years or so, and we're already worried about, are we going to blow ourselves up with nuclear bombs? So you have technology pluses and minuses. One plus is now you can talk to each other on the other side of the planet, but the other side is you race that technology forward. Maybe you have nuclear bombs, or maybe you develop AI that wipes your organic life out because you've made some stupid mistake with your computer program. So of that life, is it able to have a stable enough program to last for 1,000 years, 10,000 years? And in that time, are they able to develop to the point where they could send and receive messages throughout the universe? Then out of that, how many of them are going to be close enough to us that if we received a signal that we were able to detect, would we then be able to respond with a broadcast and have any sort of communication? Because by the time that we got their signal, maybe their civilization already died. Maybe by the time we send them a signal, by the time they get it, we've already killed ourselves off as a species. And so the idea of being able to communicate is very difficult. I think the best odds are maybe even being able to detect something, if that's possible. So far, the Seti program has been going on for 50 years, and they haven't detected a signal of any intelligent life. That doesn't mean that one hasn't been transmitted and when we've missed it. That's also possible. But the consideration is, so far as we know, we're the only intelligent life that we've been able to talk to in the universe. And so that leads us back to a very important question. Let's go back. I have some final thoughts to wrap up this semester, and I hope that you stayed with me this far. It's only a few more minutes. So in summary, what I hope that you learn out of the course of astronomy, I want to boil it down by reading from a few books that I've really enjoyed reading through the years. One of them is The Universe of Stars, which is a collection of Harvard radio talks from around the year 1925. Harlow Shapley, you remember him, he's featured a lot in our discussions, but he, in one of them, has a radio talk that he gave. Remember back then, the radio was like the internet. So he had a radio talk that he gave called Life on Other Worlds, in which he described the conditions necessary to life. And he records 7 conditions in here. I won't go through them, but it's kind of basically the same summary that we saw at the whiteboard. But in his conclusion, I'd like to read from a passage that he has here. To summarize the discussion so far as it bears on the planetary system of the sun, we can state the average astronomical opinion that is far less optimistic than for the widespread diffusion of life than the opinion of the enthusiast. In other words, the opinion is kind of low that there's going to be intelligent life, and he's at least talking our solar system. Venus, as far as we can see, most nearly fulfills the conditions that any planet other than Earth. Its mass and orbit are certainly favorable. Its distance, rotation, and chemical constitution are probably not unfavorable, but we can't penetrate the dense covering of clouds and seek out the secrets of its surface. Since that time, we've landed rovers on there and found its surface to be completely uninhabitable, by the way. Low life forms may exist on the planet Mars, where the thin atmosphere does permit our telescopic explorations. High forms of life are generally deemed improbable at the present time, and beings comparable with man and other terrestrial mammals are considered utterly impossible. The frequent suggestion that we try to exchange signals with organisms on Mars is, I think, extremely preposterous. Those absurd people who try to recommend such experiments should practice first communicating with carrots and jellyfish. If they succeed in establishing relations in that field, they may have some luck with the Martians. Now, editorial note. Since then, that was a jibe meant at trying to talk to microbial life that might be on Mars, but also the idea of us being able to communicate with any other extraterrestrial life is similar. If you look at the table that's in chapter 8 that talks about the percentage of life that's on Earth, most by percentage of life on Earth is bacterial and microbial. And so actually when he's talking about plant life and jellyfish, being able to talk to the carrots and the jellyfish, they're much closer to us in DNA regards. They have a lot more percentage comparison to us in DNA than you would have with a microbe or a bacteria. So he's not too far wrong. As absurd as it sounds, being able to communicate with plant life, they have a lot more structurally in DNA characteristics with us than do the microbes. Anyway, I'll continue. All the other planets in our solar system are now quite unsuited to protoplasmic life, failing to qualify by matters of mass, rotation, or distance from the sun. Conditions of the same sort hold for the other stars as for our sun and planets. As a star dies and cools off, it may be able to support life on its own surface for a brief time, but in general, it seems planets like ours will be necessary, and we can't assume that all other stars have planetary systems or that it's a common sidereal habit. Again, we must speculate without knowledge of the facts. A close double star in which the two members of the pair of gaseous bodies are within a few stellar diameters of each other cannot maintain a suitable planetary system. Perturbations would probably wreck the orbits quickly or hopelessly distort them, even if planets should start to be favorable for the development of a protoplasm, that being life. We can also assume by no other means that the stars have had encounters with other bodies that would produce the sort of tidal eruption planetary system of the kind that's suitable for habitation. Even if one star in 1,000 develops such a family system, it's probable only rarely that would one of those planets be ideal for our kind of life, and still rarely would those conditions be maintained long enough and free enough from disturbance of periodic variations from collisions with other bodies. The occurrence of habitable planets out there among the stars must therefore be very uncommon, even though we're not justified in assuming an absolutely unique position in nature for Earth. The members of our stellar system are numbered by the thousands of millions, and time is long,
So somewhere out there, there may have doubtless been planets besides those of our solar system suited for the complex of innumerable chemical reactions called protoplasmic life. And then skipping on down, it says, the animal man, to be sure, is probably unduplicated in the sidereal universe, and astronomically speaking, he represents such a transient, fortuitous, and uncertainly poised combination of circumstances that it would be surprising if the laws of probability exactly reproduced him. But in some form, non-terrestrial life probably exists, has existed, and will always exist, but in the absence of information, we can only surmise that the chance that its intelligence surpasses our own is about as good as the chance that it falls below our level. So in other words, the odds of there being intelligent life out there, in his view, since we know about nothing, is about 50-50. Now, another person I'd like to read from his book is Otto Struve. He came from a long line of astronomers, and he was in the 1950s. This is before the Seti project happened, but he was talking about in general, he spent the last part of his life as a radio astronomer, and this is talking about in general his idea of exchanging radio waves with another planet. We must, however, distinguish the probability that stars other than the Sun possess families of planets and the probability that there is intelligent life on any of these distant planets. Nearly all astronomers agree that there are probably many billions of stars in the Milky Way, and a lot of them will have planets, but only a few dozen such stars are closer to us than 20 light years. The probability is also great that few of those outer planets will have some form of life, but the probability that any of them have intelligent life at the present time is vanishingly small. The probability even that intelligent life exists now outside the solar system, but closer to us than 20 light years, any radio signals are now reaching us is very remote. But it is not zero, and as stated recently in the magazine Nature, the attempt to record such signals should be made. And so his view is we've only been emitting radio signals as a planet for, at his time, 20 years, and now for 70 years. And so only planets within 70 light years of us will have even heard the noise of our technology and our manipulation of the electromagnetic spectrum. Only those stars that are within 70 to 100 years would have heard that signal. And so it's very rare that anyone outside of our planet, of our planetary system, would have heard us talking, so to speak. And last, I'd like to read from some of the words of The Cosmos of Arthur Holly Compton. I can't claim familiar relation with him. As far as I know, he's not in my Compton family tree, but he was a great physicist from the University of Chicago. Let's see what he had to say about it. A notable second fact about man that emerges is that science seems at the present time incapable of giving any clue of how man's awareness is related to what happens in the world of physical matter. Our studies of physical science have given us no clue on how it is that we think, feel, and choose. The development of so-called thinking machines, computers, has brought sharply to our attention the fact that responses to stimuli don't necessarily imply awareness. Awareness or consciousness in the category distinct from our own objective science. It is something that each of us experience subjectively, and hence we know more about it than we do the external world. We can find by experiment how our own conscious life might be affected by internal and external physical conditions, but as to how this consciousness comes to be, or how widely awareness in general throughout the universe can be, science gives us little guide. That's referring to intelligent life. Man knows himself as an observer of the world around him, and he can influence that world to work within certain limits to his own desires. And with all that science has done, however, man remains separated by an impenetrable barrier from sharing any awareness that other portions of the world might have of the drama that's happening in the universe. No avenue has opened where we may gain reliable knowledge from observing the world around us as to whether consciousness exists anywhere aside from outside ourselves. It is possible that the physical sciences may, in principle, describe completely the structure and actions of man as part of the material world. And that he's saying it may be possible that mankind might figure out the physics of what's happening in our brain to say how it is that we come to be thinking machines. But from what we've just seen, however, it's clear that man is not so far completely accounted for. Left wholly out of this consideration is a description in the realm of sensation, of ideas and ideals, of understanding and emotion, that gives human life significance. Just as these things reveal themselves to our own consciousness, likewise we recognize them as factors that give inherent value to other people. This value of our fellow human beings is not proved by science, but the way is left open by physical science for such values to have meanings for us. Thus, it is the recent remarkable growth of science and the very process of extending our knowledge in the physical world that has shown us more sharply what our limitations are. Physical science is concerned with the material world. It shows us the framework that is the basis of our lives, but it is not in the character of science that it shall be capable of opening to a man a knowledge of his most inmost soul. So science can tell you what you're made out of, but science can't tell you why it is that you think how you think. Now, there's one last summary that I like to make of all this material in these couple of chapters. There's an idea called the Anthropic Principle in philosophy that says the universe is like it is, not because there was a God or a creator that made it special, but that without the universe being exactly like it is, we wouldn't exist. And they point to something, you can point to something like the fine structure constant, and the numeric value of 1 over 137. And what is the value of 1 over 137? It's kind of a combination of all of the different constants and equations that there are to say that for the electromagnetic force, the nuclear force, all these things to work like they do, this constant has to be what it is, 1 over 137. And what that allows for is for fusion to happen in stars, for that fusion to produce carbon, for that carbon to later on be involved in the development of life on Earth as we know it, and for that to eventually wind up resulting in us. Now, the Anthropic Principle would tell you that it is as it is because it has to be as it is because we're here. And the idea is that human beings can only observe the things that we can observe because we've developed to have the sense organs that we have. We have eyes and ears and a brain to think about them. And so the things that a human being can notice are only the things that a human being would be capable of noticing, which is kind of a circular argument. But the idea is also the argument is also made that the Anthropic Principle and the fine structure constant point to the fact that the universe was set in motion for us to be like we are. In other words, the planets were set to be where they are. The sun was set to evolve how it evolves. All the other stars that contribute to making us were done so for the express purpose of us being here. And so without all those things being set in motion just perfectly, we wouldn't have an Earth and we wouldn't have human beings on them. And that points to some sort of intelligent design or creative design. Well, whether or not that's the case, whether or not, even if you choose not to believe in a God that put us here, but if you just look at the fact that human beings are special and we occupy a special place on Earth in this time period, we are the only beings capable, as far as we know, in the universe. We're the only beings capable of contemplating the universe that exists. So for all the multitude of galaxies that are out there besides the Milky Way, for all the multitude of stars that are out there, for all of the different planets that are there, none of them that we know so far has shown any signs of life or for that matter, intelligent life. And so as far as we know, you and I and all of our brothers and sisters here on Earth, we're the only ones capable of consciously thinking and contemplating what it means to exist. Even our close relatives, DNA talking, chimpanzees and apes and orangutans or whatever, as far as we know, they're not capable of conscious thought of being able to contemplate what their existence means. They don't produce artwork or any other way to communicate with us, to express. Some maybe have pointed at themselves in a mirror, but that's not the same thing as contemplating their existence in the universe. And so, as far as we know, mankind is special. And mankind is where it is, not because Aristotle believed that we're at the bottom end of the universe and all the trash filters down here, and that's why man has wound up where we are. No, the Earth revolves around the sun revolves around the center of the Milky Way galaxy, and we have characteristics that have produced life here on Earth, and you and me. And however that has come to be, I as a Christian believe that it is because God made it that way, and that's how we are where we are. But regardless of what you may think about how we got here, the fact is that you and I are here, and your neighbor and your friends and your family and your enemies are the only ones briefly able in this great universe that we live in to contemplate the beauty and the majesty of what is here. To be able to look at the stars at night, to be able to consciously think about our position in the order of things, to be able to think about what lasting impact we might make on why we should educate our children and why we should give our children values, so those values perpetuate themselves, so that our earth becomes better and that our human existence becomes better as our interactions with our fellow human beings become better. And so I would encourage you to continue your study of the stars, to keep on looking up at the stars, because they should point themselves back to you and how special you are as an individual. And I believe that's because God made you how you are, and that you should interact with your fellow human beings knowing that, whoever they are, male or female, whatever race they are, they're all individual people. And those individual people are the most special thing that there is in the universe, because they're the only thing that you can communicate to and that they can communicate back, and you can have a dialogue. And as far as your own existence inside your head, you know what's in your own head, but being able to compare that by speaking and listening to what other people have inside their heads is a very special and unique thing that's only possible because we have a conscience and we're able to communicate with each other. So I want you to take that with you out of this study of astronomy. I hope that Openstax has been an interesting study. I know this last video has been long, but I promise the quiz related to it will be short. So hold off a little bit of hope there. But do consider this, how over the course that we've looked at what it takes for the Milky Way to produce stars like ours, for the star like ours to produce planets like ours, and for Earth to be where it is in the universe is a rare and special and unique thing. And you should be sure and be kind to one another, because life is short and you're only going to be here for a little while. And so everyone that you come across, you should treat with respect and kindness, because that's the important thing as you go on your journey through this earth. And Godspeed. I hope that this finds you well, and that you continue your life after your study of astronomy, that you continue your life with an appreciation for how special you are on this planet Earth.